Welcome you all to the Research Spark YouTube channel. So this is the another course that we are going to discuss here. So currently we are going to talk about the electromagnetic theory and interference, having the subject code of 21ECC205T. So first we are going to talk about the unit first. In the unit first, we will discuss mostly about the electrostatics. So here is the syllabus. Just check. First, we will talk about the basics of the electrostatic. Then we'll see the some coordinate system, rectangular, cylindrical, and spherical, followed by the some vector calculus problems. Before starting the course, here is the some key equations that you should remember. That is the divergence of your D, that is the field intensity, electric field intensity, is equal to rho of V, that is the charge density, and then the divergence of B, that is magnetic field, is equal to 0. Curl of E, that is electric field intensity, is minus of dV by dt, and then the curl of the H, field intensity, magnetic field intensity, is equal to J plus del D by del T. Okay, so let's just start the introduction to the electrostatic. So what exactly the electrostatic means? Electrostatic means the electron and the static. So actually, while we are talking about the electrostatic, mostly we are talking about the charge, and where it comes from. Charge exactly from the electron. Electron is the unit particle having the some charges. Charges is exactly the value is minus 1.6 into 10 to the power minus 19 coulomb. Also, you can check the another properties like mass of the electron is 9.1 into 10 to the minus 11 kg, and the spin is electron has 4 minus with the spin half. Then the nature is elementary particle and located in the fundamentally in the atoms. So if you remember, then you can find your electron in any atoms, like the electronic configurations. If you remember, like 1s2, 2s2, you are writing so on for your silicon atom or any types of the the elements. So basically we are going to talk about those electrons having the charges only. So that is mostly here we are going to focus on the forces because of the electronic charge or the charges, then the fields because of that, again the charges, and the potentials associated with the only static. Before going to talk about the electrostatics, so we are having the sub background. So you can find all these backgrounds in your mathematics. So here is the how can you locate any particular point. So we can have the three types of the coordinate system. First is your Cartesian coordinate system or the rectangular, where we can move across the x-axis, y-axis, and z-axis in 3 dimensions. Similarly, in cylindrical coordinate system, you can move across the radial direction, that is rho, and then the another angle, that is the phi, and then the height z. So this is a little bit different from the Cartesian system. And so how can you change from one coordinate system to another coordinate system? So here you can find this rho. Rho is nothing, and the root is square root of x square plus and y square. And how can you relate your phi, this phi into your Cartesian system? So that is tan of x is tan of phi is equal to y by x. So with the help of this you can change. Alternatively, you can write your if you are changing, this is phi. If you are changing from your cylindrical to Cartesian, then your x will be rho of cos phi, this one, and then the your y will be rho of sine phi, because this is your rho and this is your angle phi. So how can you convert into your cylindrical to Cartesian or Cartesian to cylindrical? So there is a matrix. So nothing is this, simply if you will use this conversion, your rectangular to cylindrical and cylindrical to rectangular, along with the direction, you will get this one. Similarly, there is another coordinate system which is being used to locate a particular location. So how can you reach to a certain location, point P? So first one radius r, and then another first angle phi, and then another angle, that is theta. So in this way you can reach a particular location. And again, how can you convert from cylindrical to spherical to Cartesian, or Cartesian to cylindrical? So r, this point OP, that is r is equal to under root square root of x square y square and z square, and then angle theta you can find tan inverse square root of rho square divided by z, or the square root of x square plus y square by z. Similarly, you can find the phi as usual cylindrical system. Here, how can you convert from your spherical to Cartesian? So x is equal to r sine theta cos phi, y is equal to r sine theta sine phi, and z will be the r cos theta. Similarly, you can change using this matrix from the spherical to Cartesian and Cartesian to spherical coordinate system. Here is the practice. So you should do first, this is a point P that is having the coordinate in the Cartesian system of -2, 6 and 3. So how can you convert? Since this is the only the point, so you can use the the point formula to change. Similarly, if you wanted to change the matrix, wanted to have the your vector A, since it have the magnitude and direction, so must use the matrix to change it. Now, next to your coordinate system, let's come to the vector. So let's talk about the some basics of the vector, then we'll talk the some vector calculus. So what do you mean by the vector? So vector have the both magnitude and direction. So what do you mean by this magnitude and the direction? So here is the direction. A of A is A, that is your original vector, divided by the magnitude. Magnitude you can find using the A is equal to the root of ax square plus ay square az square. Ax, ay and az are the components in the direction of the x, y, z. And so you can find the A of the direction of A, that is the vector, and divided by the magnitude of that particular vector. And now if you wanted to find the dot product, cross product, then how can you find? So dot product means the dot product of two vectors, like A dot B will be equal to the A into B, and then the cos theta, that is theta in between the two angles. So similarly you can write having A dot B is equal to AB in the x direction, AB in the y direction, AB in the z direction. And the cross product A cross B is AB sine theta, and the direction will be the perpendicular to both the A and B, moving from the A to B. You can find it by the either right hand rule or the script. And how can you find the value of your A cross B? Using the matrix, that is the direction ax, ay, az, then the magnitude ax, ay, az, and magnitude of another vector, that is bx, by and bz. So you should try to solve some problems on these. These are the very basic and the elementary things. Next to this is your differential length and the area and the volume. Actually, our target is to find out these things only. That is, how can we have the differential length, area, volume. So basically, we are going to focus on the length. So differential displacement can be given by d of L, that is d of x in the direction ax, and the d of y ay, and d of z into az in this Cartesian coordinate system. Similarly, in the Cartesian system, your differential area will be equal to dx dy, or dy dz, or dy dz dx. Volume will be the dx dy and dz. Very simple one. And you can change these things, your differential length, your area, and the volume in the cylindrical and Cartesian, the spherical coordinate system, using the formulas that we have discussed in the previous slide. So you can go through that. And what is the Dale operator now? So Dale operator is nothing. This is actually the how can you find the differentiation Dale operator by using the Dale operator of any vector. So we are having the Dale, that is equal to the derivation of your d of dx in the direction of ax, and del of del y in the direction of dy, and the del over del z in the direction of the a of z. So using this Dale operator, we are going to find the measure for four types of the operations. So first is a gradient, that is the scalar vector product of your del, and then the divergence, that is the dot product of your particular vector A with del operator, and then the curl of your del of your with vector will be the curl, and then the Laplacian, that is the scalar vector del square. Del operator can also be written in the form of the cylindrical. This one is your cylindrical and this one is your spherical coordinate system. However, this one is most important, that is in the Cartesian system only. So we are going to discuss about this Cartesian system only. So here is the gradient. So first, what we told exactly, the gradient means simply the del operator with the scalar quantity. Means suppose v is a vector having the some direction, and if you are taking in the scalar derivation, then it will be called as the gradient. So here v, you are going to take the derivation along with the x direction, y direction, z direction to the entire v without any product, any other. So this is the scalar one. So del of v can be written as del of v divided by dx in all direction, del of v divided by dy in all direction with the ay, and then d over del z dz. Similarly, your gradient can be obtained in the cylindrical and the spherical system. So here is the divergence. So how can you define the divergence of A at a given point P is the outward flux per unit volume as the volume shrinks about P. So how can you find? So del of A, that is the dot product of your del product del and A, that will give you the divergence. So that will be your del of Ax divided by x. Here A having the quantity only in the x direction. However, if you remember the gradient in the case of the gradient, v having the direction of the entire magnitude. So here only del of ax divided by dx, del of ay divided by del y, and del of ay divided del z divided by del z. There will not be direction because the dot product will be the output of the dot product will be the scalar quantity. And similarly, the del product, that is the divergence, can be obtained in the cylindrical, and this one is your spherical coordinate system. Now here is the curl. Similarly, so curl of an axial vector whose magnitude is the maximum circulation of A per unit area as the area tends to 0, whose direction is the normal direction of the area when the area is oriented so as to make the circulation maximum. How can you find? So del, that is our curl of A, is equal to del cross A, that is curl operator only, and the output you can find using very simple technique, that is direction ax ay az, del y del x, and del y del z, and del y del z, ax ay az. Solve it, you will get. So this is similar, that is we have already discussed how to solve the curl of a vector. So that's all in this first session. We will talk about some Coulomb's law and the field intensity and the problems. We'll see the based on the Coulomb's law and that electric field due to the continuous charge distribution and derivation of the electric field intensity due to the line in our next session. Thank you for us. If you wanted to visit the channels, you can visit with this link. So thank you for listening me.